Welcome to episode 3 of the Stronger by Science podcast. We've gotten a lot of great feedback on the first 2 episodes, so we are going to start releasing episodes every single week from now on. Every other episode is now going to be a question and answer episode in which we answer questions from listeners, and this is the first such Q&A episode. If you'd like to have your questions answered on a future show, check out the links in the episode description to submit your questions to us. Thank you for listening, and be on the lookout for new episodes dropping every single Thursday. What we're going to do is go through some questions that we have collected on social media. Please continue to give us questions that you'd like answered on the show. Anything to add, or should we jump right into it?
In the show notes of this episode, I'll link the social media posts where we originally solicited questions. Because there is absolutely no way we're going to be able to make it through all of the questions that came in this time. So we're going to kind of keep like a rolling list of questions and try to get to everything. But so we don't want to overlook the people who asked these questions initially. But if you ask a question, it may take us a while to get to it. But we're going to try to keep everything kind of in one spot to make sure we don't miss anything.
All right, question number 1. What advice do we have for 40-plus year olds working out? You know, people who are not newbies but haven't made the progress they would like. Should they simplify and reduce workouts, or just continue doing whatever they can recover from? How do you address aging when it comes to training? And that's from Doug.
Yeah, so that's a good question. And I would say that the age of the person we're talking about matters quite a bit here. So when someone says 40 plus, there's a big difference between like 42 and 72. And typically, I'm not going to worry too much about aging for men until someone's like mid 50s or higher, and for women until they're postmenopausal. That kind of seems to be the age where like interesting things start happening from like a senescence perspective. And when there is like a reasonably steep decline of just things physiologically. Yeah,
because I should mention there's another question by Matthew asking, what are the primary reasons that older athletes aren't able to perform and recover as effectively as younger athletes? So
Yeah. So for someone who's like in their 40s, and let's say they've been training for, let's say like 3 or 4 years or something like that, I honestly wouldn't take age into account all that much. For the most part, you're just looking for the same signs that any other athlete is looking for. So, you know, are you feeling reasonably fresh when you go to work out? Are you kind of accumulating like wear and tear type nagging discomforts? And for some people, some people who are in their 40s are in much better physical shape than plenty of people in their 20s, and vice versa. So like, if you compare the populations of 40 somethings to the population of 20 somethings, like most physiological things would kind of be in the better direction for the 20-year-olds. But like those two distributions are going to have a ton of overlap still. So I would pay more attention to just how you're feeling as an individual versus how you're feeling as someone in their 40s. So I don't really think that without any additional information, I would make like proactive changes to reduce volume or reduce frequency or anything like that. If you're still making progress and still feeling good, those things could absolutely stay where they are or even go higher. If, like anybody else, you're feeling worn down and feeling like you can't recover and you are doing a good job of taking care of business outside the gym, then yeah, like pull back. But that's because you as an individual aren't recovering, not you as a 43-year-old aren't recovering.
Yeah. I feel like if you look at the exercise science textbooks, they kind of oversimplify it, and you kind of see the graphs they draw, and it's like once you hit like 35 or 40, there's this kind of steady decline. But in the real world, that just doesn't seem to be the case. Like, I mean, I know plenty of natural bodybuilders who looked better and better and better well into their mid 40s, you know? So I'm kind of the same opinion, like rather than take a defeatist approach into it and be like, well, I turned 40 yesterday, so I should completely restructure what I'm doing.
Yeah.
It's probably better to just be reactive than to try to get out ahead of it.
Yeah, like Jen Thompson is in her 40s, still getting stronger. Marissa Inda's in her 40s, still getting stronger. Fucking Dave Ricks is in his 50s, still getting stronger. Or actually, I haven't seen much in the way of competition out of him recently, but I know that I'm pretty sure the meet where he hit his all-time biggest raw total, he was 53, at least up to this point. So, like, yeah, just worry about yourself more as an individual and how you're feeling and responding to training. And like I said, if you're, if you're like 65, 70, like time's really not your friend at that point. And okay, now maybe you are perhaps at a increased risk of injury. You've probably accumulated a lot of like wear and tear stuff if you've been lifting your whole life. Now maybe it is time to be a little more proactive, to decrease volume a little bit, maybe change training to add in a little bit more explosive stuff. There's some research looking at older adults and maintenance of type 2 muscle fibers, and like high power type training versus like high force type training seems to be pretty good for maintaining type 2 muscle fibers and like functional capacity with age. So yeah, when you're turning 60, 70, like those might be some changes you want to make. 40, 50, like I really wouldn't worry about it too much.
Yeah. You want to read the next question?
Yeah. Well, so I don't think we answered Matthew's question very, very well. What are the primary reasons older athletes can't perform and recover as effectively as younger athletes? Do you want to take the first stab at that?
Well, I think the kind of the most glaring thing that happens as we age is we see big changes in hormone levels once you start getting to that 40, 50 range. So it's usually around the time that a lot of women hit menopause. And so there's obviously big hormonal changes there. And then with men, testosterone, that's usually around the age where it starts to really taper off. So anytime you're talking about being able to train effectively and recover and maintain body composition the way it has been, certainly changes in sex hormones are going to be a big influence on that.
Yeah. A couple other things I would add that I think are overlooked a lot is one, for the people we're talking to who are probably more like the powerlifter, bodybuilder type folks, or at least have goals related to like building muscle, maintaining decent body comp, getting stronger. Those things probably aren't going to drop off as fast as, say, like explosiveness would. And one point I always like to make is I think one of the reasons people kind of zero in on like, ooh, like mid 30s or like, ooh, I just turned 40, like things are really going to start going downhill, is you're looking at professional athletes, and there's a big difference between you and a professional athlete. Especially you as someone with like strength/hypertrophy type goals. So one of the major reasons that professional athletes really start dropping off in their 30s and 40s is one, just like wear and tear from their sport. If you've been, playing football or playing real football, soccer, or if you've been like playing basketball for, 8 hours a day for 25 years, your body's just experienced way more wear and tear than it would have if your training was lifting weights for an hour and a half, 4 times a week. So the kind of physical aging process is going to affect them more just because they put more wear and tear on their bodies. And then 2, those sports are going to be really dependent on speed and quickness and power output. So like something like that would affect a weightlifter as well. So changes in the nervous system occur such that you can't recruit all of your muscle or all of your motor units quite as quickly. You can still reach full recruitment. It's just not going to be quite as snappy. So like velocity is going to drop off a little bit. Power output's going to drop off a little bit. You get changes in connective tissue. So you lose some of the elastin in your joints. So they're not going to be quite as good at like helping with plyometric type movements. So like none of those things are directly affecting force output or are necessarily going to be related to whether you can still build or maintain muscle mass. So like it's going to be really, really obvious if you're a 40-year-old basketball player and can't jump quite as high. And that could really affect your game and how effective you are on the court. But it's probably not going to affect someone who's, just trying to add weight to their bench max. So don't expect that your physical decline, relatively speaking, is going to be as severe as that of a professional athlete, just because like the things that affect how you can do in the gym aren't going to drop off as fast as the things that will determine whether someone's effective on the basketball court or the soccer pitch.
Yeah, I mean, you and I have a lot of mutual friends that they study, nitty gritty neuromuscular stuff in the lab. And just in conversations with them, I'm not an expert in that particular area, but they always mention that when it comes to sport performance, the rate of force development or the rate of torque development is where a lot of the magic is for a lot of sports. And they also mentioned that that's kind of one of the hallmarks they see when they do studies in older versus younger people is not the total force that gets achieved, but the rate of force development. So, yeah, I mean, that stuff starts to drop off a little bit, but that's not going to stop you from grinding out reps in the gym on a traditional strength or hypertrophy program.
Yeah, like your max will be fine. Your bar speed's just going to be a little lower.
Yeah.
I think you can probably take this next one. Tomas Kozan asks, according to the conclusions of this Churchward-Venn study, and then links the study, we can put that in the show notes. Do you believe that from a long-term muscle protein synthesis standpoint, it would be equally beneficial for a person to eat 5 grams of leucine plus 6 grams of protein at breakfast, as opposed to 30 grams of protein at breakfast? If it's simpler and easier to eat a small breakfast instead of the addition, basically asking about like leucine threshold type stuff. Are you better off just reaching your leucine threshold from eating like whole proteins versus like some smaller amount of full proteins, but then adding in leucine to hit that leucine threshold and hopefully having enough of the other amino acids in your system?
Yeah. I mean, this is kind of from a long line of studies that do similar approaches, right? Where they'll say, like, what if we give a really tiny dose of protein and we give it some branched chain amino acids or some leucine, or there's all sorts of combinations and permutations of this kind of research paradigm. And they generally look at some postprandial period of, a couple hours after the meal or, 4 hours or a handful of hours. When I look at this kind of research, I think it's interesting from a mechanistic perspective of trying to figure out what is really initiating protein synthesis. But in terms of real-world tangible outcomes, you have a really hard time convincing me that a super small dose of protein with just a bunch of leucine with it is going to, in the long term, pan out and be approximately equivalent to having a decent amount of actual whole protein intake. Obviously, when we look at protein intake, certainly if we want to maximize muscle protein synthesis, we're going to have a decent amount of leucine in there. But we also know you're going to have the rest of the essential amino acids in reasonable amounts. You need all of those building blocks there. And you were actually telling me in the car in Kansas City about a recent study that was suggesting that even non-essential amino acids might have some kind of secondary role when it comes to the kind of the body composition effects of protein intake. Weren't you telling me about that?
If I did, I don't remember.
Yeah, I feel like
I know there's some interesting research that I haven't looked in too much to on glycine specifically. Most of that research is done in like livestock. So like adding specific amino acids to livestock feed and how that helps with like overall development and especially like adding more muscle, which people will then eat. Glycine seems to be pretty clutch, even though that's, if memory serves, not an essential amino acid. But yeah, I haven't looked into that too much.
I believe you were telling me there was a study suggesting that a lack of non-essential amino acids was, they were linking it to maybe hyperphagia, like increased appetite. Is that ringing a bell?
Yeah.
So, I understand why these studies are done. I think they're valuable in terms of understanding kind of the pure basic physiology of what initiates, acute muscle protein synthesis. But for most healthy people, I think if you want to take these literally as like practical strategies to change your diet based upon, I think they're largely attempts to solve non-problems. You know what I mean? Like, so what if instead of having a delicious food for breakfast that I very much enjoy, I had an 11-gram amino acid mixture,
Well, and that's really the kicker right there, man. Because, like, chicken's delicious, steak is delicious, eggs are delicious. I'm not personally a huge fan of, like, tofu, but I know a lot of people find that delicious. But, like, leucine powder's fucking disgusting.
It's not good.
And so then when you talk about, like, diet adherence, like, what's someone actually going to stick to? Like, I don't know, man. I'm not going to want to take leucine powder 4 times a day for the rest of my life.
Yeah, I don't see, again, assuming you're of good health and there's no reason you can't eat, a whole protein source. I just can't see the benefit to saying I've cheated the system, and instead of having a normal meal, I've had 6 grams of whey with 5 grams of leucine in it. Mm-hmm. And like, I'm really stoked about that. The other thing is when we get out of that, short-term window, following the feeding, that little postprandial window, I still just struggle. I struggle just in terms of face validity to believe that with these kind of mixtures where there's really minimal total protein and just a ton of leucine or a ton of branched chain amino acids, I struggle to believe that in the long term they're going to have equivalent effects on overall skeletal muscle balance.
Yeah.
I really struggle with that just based on the small quantities of the other essential amino acids. And it's possible that down the road there might be more research indicating that the non-essential amino acids are still fairly important in the diet.
Yeah, and the one place where I could potentially see it being useful, and this is still kind of a stretch, is if someone's like prepping for a bodybuilding show, and your carbs are really low, your fat's really low, and now instead of like 30 grams of amino acids from a full protein source, now you can get by with like 5 grams of protein plus an extra 5 grams of leucine or essential amino acids, and now you freed up like 20 grams of amino acids essentially, which would be similar to like 20 grams of carbs, and like now maybe your carbs can be slightly higher, or you can eat a few more grams of fat. Like in a situation like that where everything is so tight, potentially there's some efficacy, but like for a normal diet, I just don't see who it would be useful for.
Yeah, see, the place that my mind went with it was more clinical. So I was thinking if you have some kind of like severe GI condition in which, you're really struggling to get food in, or maybe even in like super clinical situations where they're doing like tube feeding and they're like, how do we do more with less here, basically? Mm-hmm. And again, like I'd be stoked if research came out and said, actually, we tested this over a 4-week period with resistance training and muscle protein balance was totally equivalent. And instead of eating 130 grams of protein a day, their total energy from amino acids was down to a quarter of that. I'd say awesome, but I still probably wouldn't do it. I think it's cool, but more importantly, I'm very, very skeptical that would really be the case when you talk about not just short-term changes in synthesis only, but looking at net balance over weeks and weeks and weeks with resistance training. I struggle to see how that total amount of amino acid is actually going to support balance, let alone net accretion in skeletal muscle.
I agree. All right. Moving on to the next one from Jargy T. What's your take on long-term spinal and joint health when it comes to lifting frequently for years on end, especially with frequent heavy movements that load the spine? I worry that when I'm 50, I'll just be crippled. I don't even move particularly heavy weights, but still a concern. ...
This is super relevant to what we were talking about at dinner the other night.
What was that?
For a man who forgets no facts, you forget every aspect of your conversations.
If someone like asks a question where the answer to the question is a specific fact, I'll know it. But like if it's a vague thing, like this reminds me of what we talked about at dinner the other night when we talked about 40 different things, I'm not going to filter that down to like the one conversation topic.
We were talking about how a lot of people that lift, in terms of imaging, they're likely to have some kind of abnormality in their spine eventually. Mm-hmm. But that in many cases, it might not actually be symptomatic or require any kind of invasive treatment.
Yeah.
But we talked a little bit about spine health in lifting and the simultaneously awesome but really sobering Ronnie Coleman documentary. Mm-hmm. Ronnie Coleman has a special place in my heart because when I first got into bodybuilding, it was like just on the tail end of his career. Mm-hmm. And like he was just so special. But anyway, you want to take this one?
Yeah. So the only study that I've seen that's looked at rates of joint degeneration in lifters versus non-lifters kind of chronically was a study by Fitzgerald and colleagues back in 1980. And what they did is they recruited folks who were pretty high level powerlifters and weightlifters, and then they recruited age-matched controls. And I don't think they looked at the spine in that study, but they looked at, I believe, wrist, shoulder, hip, knee, and elbow. And just looked at like cartilage thickness and what proportion of each sample had signs of like risks of osteoarthritis or like actual osteoarthritis. And in that study, they found that rates of joint degeneration were very similar for the lifters versus the non-training controls. And I want to say the people in that study were like in their 40s and had at least like 10, 15 years of lifting experience. So pretty good sample for that. But the catch for that study is it doesn't account for survivorship bias. So it very well could have been that those were the folks who had stuck with lifting that long because their joints were just quite robust and could take it. And maybe 80% of the people would have never made it into this study in the first place because their joints all broke down before they would have qualified. So that's like a possible interpretation issue with that study. So in terms of like frequent loading, I kind of think that, and I have no research to back me up here, but I kind of think like some people are fine and some people are just kind of screwed. TBH. Like, I think like there are some folks who just go hard and do a bunch of dumb shit for like decades on end and are fine. And there are some folks like you look at them lift, everything looks fine. Their training program is generally sane, but like they're constantly hurt. Like something is always wrong. And so like this probably isn't a very helpful answer, but for some folks, I think you just kind of have to take things easy and play it safe, or you're probably just going to run into issues, and some folks are just much more robust and can get away with a lot. There is some research looking at like different genetic markers and injury risk in athletes that basically comes to that same conclusion, that some folks just have like different genetic variants that make them much more robust to injury, and some folks like if they're training reasonably hard for a reasonably long period of time, they have a much higher injury risk. So I think like for anyone, you can do like the general smart things. Make sure your technique is good. If you have any joint issues, be pretty conservative with them. Make sure you keep a good training log. So you see like, okay, my shoulder's bothering me. If I look back over my training for the past couple of months, here's how it's looked. Okay, make a note of that. Shoulder gets better, start training again, start taking it easy for a while, shoulder's fine, start ramping up volume or intensity. Okay, now I have shoulder issues again, look back. Oh wait, my shoulder started bothering me here when I was doing about the same amount of volume as what I was doing previously. Okay, maybe I just don't go quite this high anymore. So yeah, just letting your body be your guide, making sure you're keeping good records so you know where those thresholds are for yourself. And for some people, like I said, you may be able to get away with a lot. And for some people, it may be like a much, much lower threshold.
Yeah. I think something that is worth mentioning is, first of all, you mentioned variation between people. There can be so much variability in terms of how certain joints are physically structured.
Oh,
just
for sure.
Joint geometry in general. And I think that can dictate a lot of what you can get away with. And so, like, one of the very glaring examples of that is the shape of the acromion process.
Yeah.
Some people are just screwed, and it's just shaped like a big giant hook. And it's like, you know what? Like, overhead pressing is gonna give you problems, man. Like, if you're not extremely cautious about it. Another one is...
Like, sure would be a shame if that supraspinatus tendon came anywhere close to me.
Exactly, yeah. Same thing with the hip joint. A lot of people, it's like, dude, like, your hips, the way that they are built, if you're not careful, you're gonna run into trouble, you know?
Yeah.
So I think that's a big thing that comes into it, that, you know, you might be the kind of person that, yeah, I can load my spine all day and not have any trouble with it, but overhead pressing, especially with higher volumes, kills my shoulder. Like, you got to play it by ear and kind of figure out for you what are the things that really seem to get you in trouble.
Yeah.
I know for me personally, it's not necessarily a volume thing, but a load thing. Like, if I do any light, like really light bench pressing, even if I'm not doing high reps with it, if it's not heavy, I can get away with kind of sloppy technique. And when my technique gets sloppy, my biceps tendon running through my shoulder, it's just brutal. Like, so much pain. So, like, the longer you're in a lifting career, you kind of figure out what is triggering pain for you, and you adapt to it. So, like, I started lifting when I was 12 and did a lot of really stupid things and had a lot of pain. And you'd think that over time, it's like, well, it's just pain on top of pain on top of pain. But what I've found, with the exception of like major injuries, is you kind of learn how to train around just the crap you were born with. You know, so like the little aches and pains are way better than they used to be.
Yeah.
You know?
So, so like you said, there are some like joints and some exercises where just shit's going to be problematic. One thing that I see a lot that gets a lot of people into trouble is they either like follow popular training programs as written, and if there's a lift that doesn't particularly work for them, they're hesitant to sub it out. So, like, for example, those people with an acromion that just doesn't really allow for high volume overhead work. Really after like 531 got popular, like overhead pressing got really popular and kind of like general strength training when it had been out of favor for a while. And for a lot of people, for most people, overhead press is perfectly fine. For a subset of people, like, overhead press is probably going to cause issues. But like, they follow the program as written, and wind up with problems if they would have subbed out overhead press for something like high incline press, which would have had similar effects training wise, but may have been a little bit friendlier to their shoulders, they would have been fine. And also, like, there are a lot of, so you mentioned hips. There are a lot of people who have issues squatting to depth, where they could get the vast majority of benefits out of the squat if they just cut it a little bit higher.
People on the internet would make fun of them, though.
True. Yeah, but that's something that Stu McGill has talked about a lot. Like, a fair amount of folks of like Irish and Scottish descent, their their hip flexion range of motion is just limited compared to the majority of other people. And so like you can get to a little bit greater than 90 degrees of hip flexion, but go much further than that, you're either going to be like at end range of motion for hip ligaments, which is not good, or you're going to have to go into some spinal flexion to hit depth, which also isn't good. And so like folks like that, squat like 2 or 3 inches above parallel, you'll be fine. Like probably lower injury risk. You'll still be able to get the vast majority of the same benefits you would have gotten from the squat anyways. But yeah, like everyone says like, oh, got to squat ass to grass. And there's some people who just shouldn't squat ass to grass. So like Eric said, like make sure you're tailoring your training programs to exercises that work well for you, and make sure you're tailoring ranges of motion for the exercises you do to ranges of motion that you can handle. One very piece of practical advice I would give is if you train at a gym where there are several like older lifters who are still getting after it, just go up to them and ask them like, how is your training different now from how it was when you were younger? And if you're someone who's kind of approaching training pretty conservatively, like, how can I minimize my risk versus necessarily how can I maximize all of the progress I could possibly make? Just listen to what those guys say and try implementing some of it. Like they have found ways that for them have allowed them to train hard for 50 years. And they found that maybe some of the stuff that they were doing 10 years into the process started causing problems 30 years into the process. They would probably have several nuggets that you could learn from and apply to your own training if you want to approach things a little bit more conservatively.
Yeah. Now that original question mentioned the spine. We also got a question from James saying, would love recommendations for lifters with spinal loading issues. The other night we were talking about the fact that if you were to just take a random sample of people that have been doing the power lifts, heavy squats, heavy deads for a while, even if you just took the general public, I think you're going with imaging to find some degree of abnormality somewhere along the spine, you would imagine, right? I would expect it to be a little bit higher prevalence in lifters. So one thing that we chatted about at dinner the other night was the fact that just because there's an imaging abnormality doesn't necessarily mean like, okay, time to cut me open, And a lot of times, I mean, obviously you have back pain, you go to a doctor, you listen to your doctor. But I think sometimes we worry a lot about, because it looks bad, right? Oh, there's 600 pounds on your back. Maybe that's hard on your back, right? Like that's a pretty intuitive kind of thought to have. But I think you also have to consider like, what if I did no spinal loading at all? And like the general population does tend to have a great deal of back pain. Like back pain is extremely prevalent. And I think there's got to be a sweet spot in the middle, right? Where there's like some responsible level of loading that when done properly and safely is not just harmless, but probably actually to some extent beneficial for spine health. And then obviously if you go too far and you're getting a little bit ahead of yourself and going crazy with it, then you're probably likely contributing to some pain down the line. Now, when it comes to people with pre-existing loading issues, maybe kyphosis, scoliosis, do you have any practical tips for that kind of situation?
Yeah, so I am someone who has spinal loading issues. And I also still attempt to be a power lifter. So I've had to negotiate this for myself for the better part of a decade now. And not just the spine, but if you look and see like what kind of are the mechanisms of injury for most joints, acute injuries are the most common when a joint is loaded to a substantially greater degree than the tissues are like accustomed to and have adapted to. And chronic injuries tend to take place when a tissue is exposed to relatively high loads with insufficient like time or ability to fully recover, and typically associated with some sort of technique issue as well, such that the tissues each time they're exposed are being stressed more than they probably should be. So I think one practical thing a lot of people can do if they have spinal issues is one, go to a physical therapist. Like that's their job, like to help you like fix injuries or reduce injury risk. Two, if you're going to be stubborn and not go to a physical therapist, shame on you, still go to a physical therapist. But if you are going to be very stubborn and do it yourself, I think a practical step someone can take is to make sure that your spine is robust to different types of loading. So one thing that I've noticed when talking to a lot of lifters who have back issues, a lot of times like the original problem didn't occur at the gym. So like, they were squatting and deadlifting in the gym and everything was fine. And then they go down to like pick something up off the floor in like a weird position and something strains, or they're like grabbing something off a shelf that's like where the center of mass of whatever they're grabbing is considerably in front of their body, and that does something weird and now their back hurts. Or like they're trying to grab something while they're also like twisted a little bit, and as soon as they pick it up, like they feel a pop, and now everything hurts. So we tend to, in the gym, really like only load our spines like in the sagittal plane, like flexion, extension, that's about it. And really we try to minimize flexion and extension as well. So like we're getting our spinal extensors really strong for an isometric contraction in a fairly neutral position, and that's like literally all we do. And so like, yeah, then you're going for a max deadlift, you get pulled into a little spinal flexion. Now you're putting great loads on your spine in a position where they're not used to dealing with load, and you wind up with a problem. So I think something that people can do is like starting with very, very conservative loads, like just take your spine through a range of motion, like through a full range of motion. So you want to do like lateral flexion, you want to do some twisting, you want to, hinge down, actually let your spine go into spinal flexion and just hang out in that position. Like if you're stretching your hamstrings or something, go like side to side, like add a little bit of lateral flexion along with the spinal flexion, and just like make sure your spine can move through the entire range of motion it's supposed to be able to move through.
And you're doing these unloaded?
Yeah, absolutely start unloaded. Yeah. And then, to once you're sure that like you can go through those ranges of motion unloaded, then just add like some very light loading into it. So there's an exercise called Jefferson curls, which is essentially just like RDLs, but with maximal spinal flexion. Try doing some of those like with a very, very lightweight. Like I'm a 700-pound deadlifter, and I never do Jefferson curls with more than 135, and typically with like a 30-40-pound kettlebell. So we're talking starting with like 10-15 pounds, like something very, very light. Do some side bends, and don't hold one weight in each hand. That's dumb and it doesn't do anything. But like do side bends one side at a time, holding a weight just in one hand, and like actually trying to see how much like lateral flexion you can get each rep. So you're training those muscles through a full range of motion. Occasionally doing like single arm deadlifts. So you're going to be getting a little spinal flexion and a little lateral flexion as well. And yeah, like just try some things like that. Start with very, very, very conservative loading, and just make sure that your spine is capable of moving through those ranges of motion and being exposed to some like very conservative loading through those ranges of motion. That will probably help your back in the gym, and I definitely think it's going to help with reducing injury risk in day-to-day life when you're just putting your back in a position it's unaccustomed to, because there will be fewer positions that it's unaccustomed to.
And a while back, you got me onto those like breathing squats, mm-hmm. where you kind of sit in the hole and take deep breaths. What do you think that would have applications for?
I don't know. I just think they're great. I think that so with breathing pause squats, one, you're going to do them really light. And as you hang out down in the hole, like generally some people go, or most people go into a little bit of spinal flexion when they're down there. So I think one, that's going to expose you to some loaded spinal flexion, but with a very, very light and manageable load. And then two, I think that a lot of people are really dependent on intra-abdominal pressure to support their spine when they're lifting. And so just by doing those breathing pause squats and like fully exhaling, again, when you're under very, very conservative loads, that just helps like your intrinsic spinal muscles figure out how to brace when they're not being given the assist of intra-abdominal pressure. So that's also something I've done that, like, I'm not going to pretend like I know mechanistically why it helps, but it's definitely helped my back a lot. And it's helped a lot of people who I've recommended do it. So yeah, possibly worth a shot as well. Again, starting with very, very, very light weights.
Yeah, I love those. Those helped me out a lot because I was having some pretty serious back pain at the time. But you told me to go light, and I didn't take that as literally as I should have. I was like, hey, I know what light is. And I didn't. I was a little bit ambitious with my weight selection, but I learned quickly. Now, another thing to keep in mind, if you have a clinical condition relating to your spine, obviously you need to have somebody in your corner that can help guide you through it. A good physical therapist, a good orthopedic specialist. But it's also important to realize that it's not like you have one spine abnormality and it's like a death sentence. Like, well, I guess I'll never do what I love again. Mm-hmm. I feel like most lifters have, if you talk to somebody that's like 45 and they're good at powerlifting, they've been told at least once in their career, well, you're definitely never going to squat or deadlift again. Mm-hmm. You know what I mean? And you look at somebody like Lamar Gant, like arguably the best deadlifter of all time.
I don't even think it's arguable.
Yeah, I mean, he's a legend. And I mean, he was deadlifting with like severe scoliosis. It was like a 30% curvature. Mm-hmm. Now, does that mean everyone with scoliosis is like, yeah, just go for it 100%? Like, no, you need to be smart. Like, obviously, any clinical condition, there's going to be all sorts of considerations that are specific to your case. Mm-hmm. But, I coach a Special Olympics powerlifting team. We've got a lifter with pretty severe scoliosis and kyphosis. He does a fantastic job and is a hell of a deadlifter. Not long ago, a couple years ago, he was pulling well into the mid 500s at a body weight of like 220.
Jeez.
He was getting after it.
That's legit.
Yeah. The thing that's awesome, like Special Olympics is cool because like you go in there and like there's a guy on our team that can bench way more than me. Mm-hmm. There have been guys that squat more than me and guys that deadlift way more than me. Like, they're freaking good athletes, man. Mm-hmm. We've got a guy who, it was like 2 years ago, he threw on a slingshot and just like loaded the bar with like 335 and just pumped out like a set of 12. Like, it was just crazy. Mm-hmm. Like, so yeah, it's a good time. If you've never been to a Special Olympics meet, go to one. They're a lot of fun. All right. Now, on the topic of the spine, we talked about those breathing squats and kind of how they help you get a little bit less reliant on core bracing if you lean a little too heavily on that and that intra-abdominal pressure. Now, we did get a question about belts. Mm-hmm. So the question is from Alex. For an advanced lifter, is beltless training useless? I can't find a way to justify it. Take two advanced lifters, one who trains with the belt all the time, the other who does a few blocks of beltless training per year. Who will be stronger?
Whoever picked better parents and has better genes. No, so serious answer. I think that there's inherent value in being able to lift heavy without a belt. I'm not entirely sure what it is, but like, so for a long time, I only trained with a belt. And I could squat like 7+ with a belt, and anything over 405 beltless felt like very, very iffy. And like, I can't prove that that's a bad thing, but it felt wrong to me. And I kind of think that, again, there's two questions. Like, one, what's going to get you the best results in the gym? And then two, what may set you up for unnecessary risk in the rest of your life. And like I said, a lot of the people I know who have like back problems, they train around for lifting, they actually initially injured their back doing some other random shit. And like, so I think if you are ever going to be exposed to spinal loading in life, and you're not planning on always carrying your gym bag everywhere to make sure you have a belt handy, like every time you help someone move or just like pick up something random, it's probably not a terrible idea to be able to also squat, deadlift, do things in the gym reasonably heavy without a belt, just to make sure you're ready for, the other 22 hours of your day every day.
And if you're a power lifter, you're like everybody's like default like moving buddy.
Correct.
Right. And if you own a pickup truck, Jesus, like you are done.
Yeah.
You'll spend your entire summer moving people.
Yeah. So what I would say is I'm not aware of any either direct or indirect evidence that would suggest that just for improving squat or deadlift 1 rep max, you'll be better off doing dedicated training without a belt. And I think there is indirect evidence suggesting you may be better off just training with a belt all the time. You can obviously lift more weight. There's some like older research by Robbins and colleagues, I believe, indicating that actual muscle activation for your quads and hamstrings may be greater when you lift with a belt, even if load is equated, which I think is pretty cool. Maybe it's just like your spine realizing like, oh, I'm a little safer, like we can pass these like motor impulses through to the other muscles a little more efficiently. Like, I don't know if that's the case. That's just kind of the story I tell myself to explain those results. But yeah, like I think it's entirely possible that just purely from a training perspective, you're better always lifting with a belt. But I do think there is like inherent value in still being able to lift pretty heavy without one, just possibly to reduce injury risk in day-to-day life.
Yeah. I mean, like you were saying, back when I was like squatting a lot, it was like always with a belt. And I felt like my spine was completely ill prepared to deal with any kind of perturbation. You know what I mean? So like, like you were saying, helping somebody move something, I'd be like, unless like everything's perfect, my spine is like not going to be able to accommodate this because it's so used to working in one plane with a belt in a very specific set of circumstances. So even like just misgrooving a squat, like getting a little bit out of my wheelhouse in terms of spinal loading, I felt super vulnerable back when I just like did only training with the belt, you know?
Yeah.
Now,
well, I mean, it's like, dude, I've heard so many stories of people who are like really serious lifters and then they just get invited to play basketball with friends for the first time in like 5 years, or like just get out and play a pickup game of soccer, and then like they strain a muscle or they like sprain a ligament or something like that, and it's like, oh well, I guess I should have seen this coming. Like, I haven't played the sport for a long time. Like, all I ever do is squat and deadlift. And it's like, people look at that and they're like, yep, should have seen it coming. Like, these tissues that I injured were ill prepared for the challenge I placed them on. But then it's like, you know, you pick something up from a weird angle in day-to-day life and hurt your spine. And it's like, who could have seen this coming? Like, I deadlift 600 pounds. Like, I thought that my spine would be ready. And it's like, well, yeah, like that quad strain you got playing basketball, like you also squat 500 pounds, but like you never do plyo. So that's like a new challenge being placed on those tissues. And it's like, you never load your spine in that range of motion, and you only load it when you have a belt to help with intra-abdominal pressure. So who cares what you deadlift? Your spine was also very ill prepared for that thing that you were doing in day-to-day life. So yeah, like I said before, just like do some stuff to make sure that your spine is robust and can do things other than perform 2 lifts.
Yeah. And that's actually a good segue. So you mentioned like things in day-to-day life. You know, there's some kind of inherent health benefits when it comes to getting stronger. Now, we had a question from Shane. At what point does someone hit the point of totally diminished returns when it comes to the health benefits of getting stronger? So like, for example, increasing a squat from 400 to 450 pounds. Are you any better off when it comes to your health or just kind of preventing injury in day-to-day life? Like where do you assess that point where, if there is a point where you're talking about diminished returns there?
Do you want to take the first crack at this one? I feel like I've been talking a lot.
Yeah. Yeah, we did get a lot of... You're the training guru, and I pretend to know about nutrition, so this has been a Greg-heavy episode, but I don't think anyone's going to complain about that. I would say it doesn't take that much to be a healthy person. So when I think about, right now I'm a world-class elite professional bodybuilder, right? Which basically means I spend several hours a week curling and doing tricep extensions. When I'm no longer a competitive bodybuilder, there's no way, man. There's no way I'm going to waste another second of my life doing a tricep extension. So, I already kind of have my plan of how I'm going to exercise after competition days are behind me. And it's going to be about loading the spine. I'm going to, keep in squats and deadlifts using very manageable loads. The goal is not going to be to break any incredible one rep max markers. It's just, is my spine prepared to age gracefully and accommodate my lifestyle? So, I see my training going more towards, am I getting in there, getting my heart rate up, cranking through some calories, loading the spine, approximating things that are going to be useful, So I'd probably do a lot of single leg lower body exercises to make sure I still have balance and stability. Train my explosiveness, because as we talked about, rate of force development takes a hit as we age. And I'll probably do a lot more of the C word, as much as I hate to admit it. I'll probably have to get some cardio in. Hopefully by that time I'll live near a body of water and I can just paddleboard all day, because that's pretty fun. But my take in it is...
Well, I mean, we're moving to Raleigh, so if global warming keeps going the way it's going, by the time we're 70, that's going to be like a seaside resort town.
Exactly, yeah. It's going to be like Panama City Beach in Raleigh. It's going to be beautiful. So my impression in terms of if you're training for life, I would say trying to maintain body composition that correlates well with positive health outcomes, getting your heart rate up a few times a week, and then making sure that you have balance, explosiveness, and a robust enough spine to basically handle activities of daily living. So I think you could live a tremendously healthy lifestyle without having a 400 plus pound squat. That's my interpretation.
Yeah, no, I very much agree. I think that you probably want to build some level of strength reserve when you're young. Because like we said, 40s, 50s, not all that exciting from an aging perspective. Maybe a little more exciting for women than men because of menopause. But 60s, 70s, especially the 80s, things really, really start going downhill. And so I think you probably do want to be quite a bit stronger than you actually need to be before that occurs. And this question mentioned a 400-pound squat. Dude, that's plenty. Yeah. When you talk about people not being strong enough for activities of daily living, it's they struggle to walk upstairs while also carrying groceries.
Right.
So, that's can you do a low step up carrying 20 pounds in each hand? If you can squat 400, you're plenty strong enough for that. Or people having issues standing up out of a chair, or standing up off the toilet.
Yeah.
So being stronger than you need to be is good, but we're talking if you squat and deadlift 1.5 times your body weight, you have a tremendous strength reserve.
Yeah.
You're going to be god awful at powerlifting. Yeah. That's not going to turn heads in the gym, but you have way more strength than you need to for day-to-day life at that point. And so I think as long as you're there or slightly beyond that, you're probably as strong as you really need to be for health benefits. And a lot of the health benefits from resistance training are in the actual strength you build, having that functional reserve as senescence starts kicking in. But a lot of the benefits are just from resistance training itself. So obviously building muscle and getting stronger is good, but there are additional benefits just from the actual act of resistance training. that are independent of how strong you are. So I think like most of the health benefits you'll get from lifting are just from lifting. And then, yeah, like I think decent benchmarks, squat and deadlift 1.5 times body weight, like you're probably fine.
Yeah. Speaking of which, you see that video of Arnold getting kicked at that event?
Yeah.
I think he was in South Africa.
Yeah.
So if you haven't seen it, the video's everywhere. He's just kind of standing in this crowd. I think it was at one of the Arnold Sports Festivals, maybe.
Yeah.
And somebody just runs in out of nowhere and like jumps and kicks him. And the Oak, man, he just like stood there and was like, what? Like he's completely unfazed, totally fine.
Yeah, and he posts on Twitter later like, hey guys, I'm fine. I thought I just got jostled in the crowd. Everything's good. It's like, he's what, like 71, 72?
Dude, yeah.
How many 72-year-olds could just absorb being blindsided by a full speed flying drop kick to like the shoulder blade?
Yeah, incredible. Like at that age, honestly, for a decent amount of the population,
that's a death sentence.
Tripping is a medical emergency.
Yeah.
Like he got freaking drop kicked, blindsided, and just like barely moved.
Yeah, so you probably need a slightly larger strength reserve to deal with the flying drop kicks we all risk in day-to-day life. But
yeah, so I actually want to revise my answer to the last question. Just to be safe for healthy aging, be the best bodybuilder in the world for like a decade.
Yeah, like knock out 5 or 6 Mr. Olympias and like keep it training really, really hard for the next 40 years. And that's probably about what you need.
Okay. So we got a couple other questions. We talked a lot about training. Now let's talk a little bit about the academic side of things. So we got a question from Brian. What would happen if Terry Tao started devoting his time to studying and publishing in exercise science, assuming he has all the resources and stuff that he needs? What kind of progress would the field make?
So just for background, Terry Tao is a Fields Medal winning mathematician. He was a full professor at UCLA in his like early 20s, like 23 or so. And I believe he's somewhere in Australia now. But if memory serves, like one of the reasons he's like famous is I think he has the highest like verified IQ ever. Which, like, at that point, I don't really trust it because, like, this typical Stanford Binet scale kind of starts getting very iffy once you get past, like, 3 or 4 standard deviations. But whatever. Like, a lot of people believe that Terry Tao, like, IQ-wise, is the smartest person ever. So, just for listeners who don't know who Terry Tao is, that's who Terry Tao is.
If you haven't been keeping up with the field of mathematics, which, shame on you. I knew all this going into it, no problem, but...
So what do you think?
I don't know. I mean, there are some really smart people working in exercise science. I think when it comes to exercise science, obviously you need to have a decent understanding of the theory and the knowledge that's already present. But I think honestly what exercise science needs is people to actually pound the pavement a little bit. Like it's an applied field in which we need human data. We need probably some changes in how we do things when it comes to collecting that data. Namely, I think we would really benefit from having larger studies. And nobody wants to do that, but maybe even multi-site studies where we start pooling data from multiple sites so that we can make larger studies more feasible. But when it comes to exercise science, when I think of like what does the field need to move forward, it's not like brilliant theorists who are going to come in and just kind of turn the theory on its head. It's really more who can actually apply the theory that we have already and the knowledge we have now, who can formulate really good research questions that are supported by very tight research designs, and then just actually put in the work of doing the large sample trials that are likely to be more robust with good study design. And I think another thing we need is better statistical training, because My perception of exercise science literature now is that the statistical toolkit is very limited because we do a lot of small studies that all kind of have the same general design. So it's like you could learn all the stat theory you want, but you're not going to be able to do anything interesting or sophisticated, because usually to do anything sophisticated with statistics, you need a pretty large sample to support it. At like big, very big.
Yeah.
So so when I think of what the field needs to really take big leaps forward, it's a commitment to really devoting to bigger studies that are done with a really strict methodology, and kind of a parallel advancement in how we analyze the data and present it. What do you think?
I agree. So I think I agree with you that the problem probably isn't like the brain power in the field, and I think that a lot of people put way too much emphasis on like the value of really, really high IQs. Who was it? Like Richard Feynman, who really influential physicist, I believe, who his IQ was like 120, and he was like super proud of that and would like tell everyone, just as like a fuck you to everyone who thought that you had to have like an IQ of 140, 150 to meaningfully contribute to physics. And I think the research tends to bear that out, that for like some like incredibly challenging theoretical questions, it may require like a very, very high IQ to be able to make progress on it. But like, I can't really think of any questions like that in exercise science.
Yeah, that's what I'm getting at. It's like we really just need data. And we need elbow grease.
Yeah, like I think we have as much brain power as we really need. And like you said, the things that would probably help the most, in terms of like being able to do the studies we would need to do to like really make like very serious progress, we need money. And so like the part of this question that asks if he had the resources of the average tenured professor, like he'd probably make about as much progress as the average tenured professor, because there's just not that many. Yeah, like we just need more resources. What you mentioned about multi-site studies, I think that could be really, really big. I think that one thing where additional funding would help with, that is often overlooked, is being able to recruit different folks than who we can typically recruit. So most training studies are done on either college students or like early career faculty who work at the university, but like mostly college students. Reason for that is if you're going to ask someone to like follow your research training protocol for like 10, 12 weeks, whatever, like you typically have to pay them. And so you're limited in terms of how long studies can run, because, you know, it's a relatively big ask to say, you know, come to the lab 3 times a week for 12 weeks and we're going to do this training program. It's a much bigger ask to say, yeah, and you can't go home for Thanksgiving break. You can't go home for spring break. You can't go home for winter break. We're going to need you to stay here over the summer. Like, there's a reason why a lot of the training studies that get published in the spring are like 10 to 12 weeks, and then the ones that get published in like the summer and fall are like 6 weeks. And it's because of spring break. Like, you can run a longer training study in the fall because a lot of times people aren't going home until Thanksgiving break. And you can run shorter ones in the spring because like spring break takes place smack dab in the middle of the semester. So, you know, you can take half your cohort through 6 weeks like before spring break and like the other half through 6 weeks after spring break. So with more money, you could then go out to like local gyms in the community and ask like adults who value their time more than the average college student does, like, hey, will you come do my training program for like 6 months or something like that? And whereas you may have to pay a college student like $75 to say like, yep, this is worth it, that's a lot of Chick-fil-A, you might have to pay someone with like a job and a family who values their time more, considerably more money to get them to agree to it. So yeah, like people ask all the time, like, man, we really need these long-term training studies. When are we going to get them? And it's like, when people get more fucking funding, man. Like,
Yeah.
that's the problem. And then, like, you also need money to pay a bunch of additional research staff because, like, if you have a PhD and you're a tenured professor, you'll probably see it below your pay grade to take 50 people through the same training program 3 times a week and, like, invest, like, fucking 600 hours of your life into just doing that. So, like, then you need people in your lab, you need funding for them to be able to do their own projects, or you need to be able to, like, pay research assistants who aren't like master's or PhD students to help out with that stuff. So, like, it really just comes down to money. Like, I think that's the main hurdle we have as the field, not insufficient IQ.
Yeah, it's the money. It's like you said, it's the schedule. Because of the money, now it's like we're basically gonna recruit college students. Like, that's how it's gonna be. And then you're like, okay, well, there's huge schedule hurdles when it comes to holidays and breaks in the fall, in the spring, obviously in the winter, and then the summer comes along, and you're like, great, we have like this huge uninterrupted block of time. Go to a college campus in July. Like, good luck finding a human being there. It's like a ghost town at most colleges. So, I mean, the logistical hurdles are huge. Another thing I think that's a problem is when you look at the timeline of a study, it's like, if it's a student-run study, it's like, well, I had to graduate. Like, I'm not going to do a 18-month training intervention because my whole degree is basically 18 months. And then when it comes to, like, young faculty members that are really enthusiastic about cranking out studies, it's like you could do a 1-year training intervention and get 1 paper, or you could do like 4 short studies in that meantime, and the people that are going to decide to either fire or promote you are going to view that as 4 times better.
Yeah.
So I think, along with emphasizing the resources, it's also a matter of taking a close look at what the incentives are.
Yeah, for sure.
So are you incentivized to do 1 really fantastic study or 4 suitable studies? And I think right now the structure, if you're pre-tenure, it is more rewarding to do 4 suitable studies than 1 incredible one.
Yeah.
And so I think those are the big things that kind of hold things back. Now, a similar question. This is a long question. I'm not going to read the whole thing. But it's Willie. And to his credit, he apologized for the long question. We forgive you, Willie. So the last five years or so, there's been a replication crisis of sorts in the social sciences and some biomedical sciences. And the question is basically, what findings of exercise physiology are you most confident will replicate? And how do you think these factors in other fields will kind of carry over to exercise science when it comes to the movement for more open science, reproducibility concerns, and things of that nature? Now, I know this is important to you. This is like a big thing of yours.
Yeah. So, first things first, I think that we first need to ask the question of what does replication and reproducibility mean. When I see this discussed, like, on social media from either, like, researchers or, like, people that just follow exercise science research in general, so oftentimes, like, there could be a body of research that is generally coming to a similar conclusion, but then, like, a new paper is published, it's asking a similar question, and it comes to, like, or it has, like, slightly different findings, and it's like, oh man, why didn't they replicate what the findings of the field were previously? And it's like, it's not necessarily a problem, because if they used a different population, they had a slightly different experimental setup, you shouldn't necessarily expect, like, the exact same results. Or if, say, there's a paper that had statistically significant findings, but it's like a p-value of like 0.03, and then another study comes out and it has null findings, but it's like kind of p is 0.2 or something, leaning in the same general direction. Those aren't conflicting findings. Like, they're the same general findings. It's just maybe the magnitude was slightly larger in one study, or power was a little greater because the sample sizes were bigger. So like one, I think you need to understand what like replication and reproducibility actually means. So one of the reasons why it was kind of shocking in psychology is they have pretty big studies, like definitely compared to exercise science. Like they'll have 200-300 people in a study, whereas we'll have 30 if we're lucky.
Yeah. It makes me furious. My girlfriend does psychology research, and a lot of it is survey based.
Mm-hmm.
They'll put a survey up on Monday, and by Thursday they have 400 responses, and they call it a day. It makes me so upset.
But yeah, so one of the reasons, like in psychology or like in biomedicine, which like those studies are more like time intensive, but they also have more funding, so they can get more people through. One of the reasons it was so shocking in fields like that is they do have big studies that that should have the power to reliably come to proper conclusions. And then the replication projects they did is they would like repeat the exact same protocol of the first study that came to these findings. So, you know, recruiting from the same population, like same method, same experimental setup, and they're getting like very different findings. So one, I think before we can really have like a reproducibility project or a reproducibility crisis in exercise science, one, we need big enough studies that it would actually be shocking if they didn't replicate, and not just like, well, we just found different results due to sampling issues.
Yeah.
And then two, like we never do direct one-to-one replications. That just like doesn't happen. So it's hard to know what the state of like the replication crisis is in exercise science, because we're not currently at a point as a field where we can know if it's a thing. The other thing I would say is, so you need to think about the factors that led to the replication crisis being a problem in certain fields in the first place. And one of the big issues was with publication bias. So you do a study and the results come in and it's like, not really the results I'm interested in. Let's just do it again. And like you said with psychology, like if you want to do the same study like 3 or 4 times, it's like, oh, well, now data collection has been extended from 3 days to like 2.5 weeks.
Yeah, and
like,
it'll cost you like, in some cases, a few $100s.
Yeah. So publication bias could exist on the end of the researchers, where it's like, well, what do I actually submit to try to get published? Or it could be on the side of the journals of like, well, am I only going to accept like statistically significant positive findings, or are we going to accept nulls as well? And I think that honestly, for all of the shade I'll throw at exercise science as a field, I kind of think that at least publication bias probably isn't quite as bad in exercise science as it may be in other fields, because funding is so limited and the amount of studies we can do is so limited that for the most part, and studies are just so time and labor intensive that for the most part, if we do something, we are really, really going to try to get it published, because, you know, you put a ton of time and effort into that. You need to get studies published to either like get into a PhD program or get hired or like get promoted. And so like you're gonna try to get pretty much everything you do published. And so I think like the aspect of publication bias on the side of researchers is probably a little bit less in exercise science than it would be in other fields. And then I think that the issue with journals is probably a little bit lower than it would be in other fields as well. So there's something called P curves. Yuri Simonson, I believe, was the main guy who came up with this. And essentially what you can do is you look at the published research in a field, you look at the distribution of p-values for the statistically significant findings that are published, and based on the distribution of p-values you see, you can get a pretty decent idea of what the power of the significant findings are, and like how many of them are probably being like p-hacked with either just like selective reporting or like statistical fuckery, like how many significant findings are being published that maybe shouldn't be. And so I checked out Journal of Strength and Conditioning Research and Medicine and Science and Sport and Exercise, which are like two of the bigger journals in our field. And their P curves actually looked pretty good. And they were actually publishing quite a few null findings. So I'm sure that there's publication bias on the side of publishers as well in exercise science, but at least comparing like the P curves I'm seeing in two of the bigger journals in our field versus some of the stuff that Simonson and colleagues found in psychology, our P curves look a lot better than theirs. So, we may not have that big of a problem in exercise science in the first place. Like the problem may just be more like our studies are small and are maybe less reliable just due to like sampling bias and shit like that. But there's not necessarily the actual like human element of fuckery leading to replication issues in our field.
Yeah, I mean, you mentioned the idea of sampling error. So if you're listening, like if you've ever looked at in a meta-analysis a funnel plot, it's a really good explanation. But when we run a much bigger study, we expect that we're getting a more precise estimate of the true effect of whatever we're studying. And then as studies get smaller and smaller, we would expect that their effect estimates are going to get less precise. So there's a lot more variability where you could do everything right, but simply because you had a smaller sample size, you might over or underestimate the effect purely based on sampling error. And ideally, you would overestimate it to the same frequency as you would underestimate it. So that's the point of a funnel plot, is figuring out, are they only publishing the studies that have fortunately overestimated this effect? Mm-hmm. You know what I mean? But I think you're right. Like, aside from the fact that these studies are small.
Well, so just kind of building on that. So I'm glad you mentioned funnel plots, because I wasn't quite sure if I should bring that up or if that would like make people's eyes glaze over. But now if that does happen, it's on you, not me.
Yeah.
But
you talked about P curves. I feel like it's your that was like the gateway conversation.
Yeah, that's true. P curves are a little more obscure. But yeah, so like I've looked at basically every meta-analysis in our field. There's a big article on Stronger by Science if you want to check it out, just to see what types of things there are meta-analyses on. So you can go to strongerbyscience.com/master-list. I think I'm like a couple months behind on that, but it is more or less up to date on like every meta-analysis in our field pretty much. And a lot of them don't do funnel plots, which they probably should. But the ones that do, like almost every meta-analysis in exercise science I've seen that includes a funnel plot, the funnel plot looks pretty good. Like there's a pretty even distribution of studies about the mean effect. So yeah, that makes me think that, I mean, it could just be that the meta-analyses that don't include funnel plots are the ones where the funnel plots would be messed up.
They checked it and they go, oh, whoa.
But yeah, but for the most part, the ones that do include the funnel plots, like the funnel plots look pretty good. And if there is asymmetry in them, like it's not bad. It's like, okay, maybe there's one or two really high values here. So there was one looking at the effects of volume on strength gains. I really wish I could remember the author's name. I met him at Southeast ACSM a couple years ago. Really good guy. But I remember that there was some asymmetry in that funnel plot. But when I actually looked at it, the issue seems to be more with the inclusion criteria for the meta-analysis than with publication bias itself. So like it was, no. It was comparing periodized and unperiodized training on strength gains. That's what it was. And in one of the studies included, it compared like a much higher volume and more strenuous periodized program versus like basically a bullshit non-periodized program. And so like the periodized group got like way better gains, And that was like by far the largest effect in that meta-analysis, and it introduced some asymmetry into the funnel plot. But like, you look at something like that specific case, that's not publication bias. That's just one study included in the meta-analysis, like, didn't do as good of a job equating other variables as the rest of the studies did. So like, of course it's going to have a substantially larger effect. But yeah, for the most part, like, the funnel plots I've seen in our field, like, they look good. Like, they don't look like the type of funnel plots one would expect to see with a ton of publication bias and likely replication issues.
Yeah, I mean, the only one that comes to mind that I saw any asymmetry was one looking at acute caffeine responses.
Mm-hmm.
And it makes sense because, like, it's not that anybody's trying to, like, do wrong, but, like, if you sunk, like, you could probably do a study on the acute performance effects of caffeine, assuming that recruitment wasn't a problem, in, like, a few afternoons, if you really had to. You know what I mean? You give the supplement, you test them, all right, wrap it up. Come back in a week, we'll do it again.
Mm-hmm.
So, like, if there was going to be a study that somebody would take the time to do it, find that their results were just simply not that interesting, and then say, I don't really feel like writing this up, it's going to be that.
Mm-hmm.
So, like, that's the only meta I can think of that I looked at, and I was like, yeah, there's some asymmetry, but what you do is you mathematically correct for it, and it didn't change the outcome in any measurable way. Mm-hmm. So, yeah, I really don't think that exercise science would have a huge issue. And you know, you mentioned, like, I think you mentioned in some of these studies or fields with bigger studies that p-hacking and some statistical trickery kind of comes into play.
Mm-hmm.
When you're dealing with small sample sizes, like, good luck. I mean, aside from, like, legitimate fraud, like, what are you going to do? Like, I mean,
yeah, or if you just want to, like, analyze a subgroup where you think the results may have been bigger, it's like, well, what fucking subgroups are you going to pull out of a study with 22 participants?
Right, yeah. So when you see these fields where it's like, okay, we have 400 people in the study, and it's like, if you just play mix and match with covariates, something might happen. You know, like, you got 9 in one group and 8 in the other in exercise science. Like, aside from just haphazardly throwing people out of the study, which is egregious and is very, very bad, and hopefully nobody's doing, aside from that, I mean, there's not a huge statistical toolkit that you can really use for evil in that scenario. So I actually think, compared to the social sciences, we probably have an issue like we've talked about, with the fact that the studies are just too small to be considered truly robust on their own.
And a lot of studies are designed poorly, or the statistical reporting is bad. Like, man, if I had a dime for every study I read that what they're looking at for an ANOVA, what they should be looking at is a, like, group by time interaction, and they see a main group effect, and they're like, oh, this group did better than that group, and it's like, nope, that's not what that means.
Really?
Yeah, I would probably have $2 or so.
if you had how much for each time?
A nickel.
Okay, wow, that's...
Yeah, I mean, so like, see that from time to time, or... Yeah, I mean, there's...
I have seen one study where they thought that they should be interested in an interaction, but because of their design, actually, the main effective group was more informative. Mm-hmm. And they're like, well, no interaction, I guess we'll try again. And it's like, why would you have an interaction? Like, based on the design, you shouldn't. Yeah.
So like you said, there's big issues with statistical literacy in our field. And so I think, like, a lot of the poor conclusions that are drawn in the literature are kind of just from people maybe not really knowing what they're doing, versus, like, actually trying to publish fraudulent research or use any of the other tools in the toolkit that could lead to a replication crisis. So, I mean, yeah, like, maybe just the small samples and the fact that our work takes so much effort and therefore isn't quite as prone to publication bias, but then also means we have small studies that you can't draw hard conclusions from. Like, those might be the saving grace of our field.
Yeah, I mean, my impression of the field is that there's no, like, glaring lack of IQ. Mm-hmm. I don't think there are a lot of bad actors out there who are being malicious with how they're handling data or reporting it.
And I think the bad actors out there tend to get sniffed out pretty quickly. Like, not going to name names, but like,
right, yeah, it's
the handful of cases that I can think of, like, people jumped on it pretty quick.
Right, yeah, it was not difficult to kind of get to the bottom of that.
Mm-hmm.
So, yeah, I think really the exercise science field in general, and I'm biased because I am part of it and have a lot of friends that are part of it, but I think it's good people who are doing their best, but it's a lack of resources that is really kind of putting additional barriers and hurdles in the way. And I would say, to be fair, a little bit of statistical training would probably go a long way.
I think that's probably a good place to wrap things up.
I think so. We were shooting for an hour and we only went over by 50%, which is fantastic for us.
Yeah. So if you made it this far, thank you for listening. There's going to be another main episode out next week. So yeah, thanks for listening to the podcast. We will talk to you a week from now. In the meantime, if you have any questions that you'd like to see addressed on a Q&A episode of the podcast, we will link my original posts on Facebook and Instagram and Twitter. If you have additional questions, just comment on those bits of social media, and we will add them to our list and get to them as soon as we can.
Thanks for listening to the Stronger by Science podcast. Now, Greg and I are not experts in medicine or health or really anything else for that matter. So before you make any changes to your diet and exercise habits, make sure you check with a doctor or another healthcare professional. If you enjoyed this podcast and you'd like to support it, visit strongerbyscience.com to check out the products and services that we offer. Thanks for listening, and we'll see you next time.